Hello, machine learning using R. Today I want to talk about how to fit multivariate adaptive regression splines, MARS. MARS is a non-parametric regression method that models nonlinear relationships using piecewise linear basis function we call hinge functions. It automatically selects nodes, locations, and builds models by partitioning data and fitting separate linear regression in each segment. Mars uses a two-stage process, a forward pass to add basis functions and a backward pass to prune unimportant terms, reducing overfitting. The method can capture interactions between variables and perform automated feature selection, making it suitable for high-dimensional problems. Mars models are interpretable and require minimal preprocessing, such as feature scaling. So it is a very powerful method. It's very flexible and adaptable to different type of data. It's quite automatic and does a lot of things like, again, guard against overfitting or automatic feature selection and all the suitable high dimensional data. Okay, so it's a very powerful. It'll be good if we can do it in R. Okay, so in R we can use the package called Earth. I don't know what on earth, why they implemented in this package called Earth. Okay, but let's see what they have got here. Set random seed, create a data set. So we get a dependent variable y and x1, x2, x3 predictors. We can fit the Mars model by using Earth, y tier the dot, and data equal to data, degree equal to 2. So the degree parameter controls the maximum degree of interaction allowed in the Mars model. So by specifying degree equal to 2, we're saying we only want up to two-way interactions. Okay, the model fitting takes no time because we have a small data set. Okay, and if you use the structure, look at the structure of the model object, it's a list of 33. Okay, so it has a lot of things in there. So you can extract a lot of information from this model fit. So first, let's look at a summary of the model. So here, this saying digits equal to 2, so we only got like 2 digits after the decimal, and the style is a Pmax. So Pmax is the basis function using the hint function, and the max style. For example, if we have Pmax of 0, x1 minus 1, then this is equal to 0 if x1 minus 1 is negative, and it's x1 minus 1 itself if x1 minus 1 is positive. Okay, so this is a piecewise linear function. Okay? And if you look at this output, you can see it actually gives us the actually fitted model. It contains some piecewise linear piecewise functions and also some two-way interactions. Okay, and here we have the I want to just interpret what's in there. One is called the reach the NK21. This indicates the algorithm stopped when it reached the maximum number of terms considered. Okay, and the GCV is generalized cross-validation number. In general, the lower of this value, the better the model. Also, we have something similar called RSS, residual sum of squares, and also the lower the better. We have GRSQ, the generalized generalized R squared, and the RSQ, the R squared. The higher, the better for these two values. Okay, so for this model, we have GCV 0.28, RSS 18, GRSQ 0.9, and RSQ 0.94. So pretty good fit in the model. Again, we have a very small data set here. But we noticed there's the number of terms at each degree of interaction. We did have 1, 5, 3. So it tells us it evaluated a three-way interaction, but it just it's maybe something happened during the process, but we specified degree of the 2, so the final model should have only up to two-way interactions. Okay? But if you want to make sure you want to print the model terms, you can use this cat format Mars model style the PMax. It actually gives you a more clear form of this model and showing you up to two-way interactions there. Okay. Okay. The Mars model fit, we can use it to generate plots. So first, just the default plots. We have 4 plots here. We get the model selection. So you can see there's there's 3 lines, GRSQ, RSQ, and I think number of predictors. And then you have the selected model. So the vertical line tells us the optimal number of terms would be 9. Okay. So, actually in the previous summary, it tells the selected 9 of 19 terms and 3 of 3 predictors. So, so it's reported we chose, not we, Mars chose the 9 out of 19 terms here. And you can see at that point, after the 9 terms, these 3 curves are kind of flat. Okay, so there's no improvement anymore. Okay, and then the cumulative distribution. This is the absolute value residues, and then you got a proportion. So this is the cumulative proportion. What you want to see in this curve is pretty much incrementally going up slowly. So if you see something like rising up very quickly and reach the plateau, that means the model is not very good. Okay. And the residual versus fitted is similar to the residual versus fitted from linear regression models. We just want to see there's no clear patterns. Somewhat closer to white noise. So that means indicate a good model fit. So here, that seems to be the case. We don't really see any clear patterns here. Okay. And the residual QQ plot similar to reflecting the normal distribution of the data. So also not much issue here. Okay. And we can actually extract variable importance using this EVIMP function. Tree equal to false. When printed out, it gives us this table with the subsets, with the GCV and RSSs. So what's the GCV values, how to use these values? So you can use the GCV values across terms. The lower, the better balance of fit and complexity. So here we see X3 is really has the lowest GCV, so it's a pretty important variable here. And you can also look into the change in GCV for variable selection. If you add or drop a variable and at least large changes in GCV, that means that predictor is influential. GCV also cross terms for model selection. You can look into the optimal number of terms when the GCV stop decreasing or even started increasing. Okay, so this is not very useful here because it only has 3 variables. Okay, let me continue this. We can also do prediction, predict the new data. No, this just because it's a predictive model. We can also print out the basis matrix if you're interested in that. And then we can plot the residual versus fitted value. That's one of the 4 default plots. We can extract the coefficient. And also we can do partial dependence plot. We can use this PDP package, and you get the 3 individual partial dependence for individual predictors. So they're all showing some kind of linear, nonlinear relationships. And also we, the the library we use is the VIP library. Okay, and we can use the PDP library, and we can plot like two-way interactions. So this is what the two-way interaction look like. So this is x1 versus x2, and for the y, and you get these contour curves, so you can get an idea about the joint relationship with the dependent variable. Okay, and also you can do model updates, very similar to with updated regression models. For example, update Mars model. Now we do a degree equal to 1, and then we can print it a summary. Okay, and R squared declined. Okay, like now it's a 72. Okay, because we're using simpler hint functions here. Okay, now we're reducing the in number of interaction. Now we only allow the mean effects, no interaction. Okay. All right. So this is uh, you know an implementation of Mars in R. I don't know how good this implementation is. I think, but at least we have something to make it happen. Okay. Okay, and if you like this video, please like our video, click on notification, and subscribe to our learning channel. And feel free to ask questions, and also share the video with other learners who might be interested. Okay, and also I will post the R codes in the comments so that you can review it and you can practice with it, and you can modify it to analyze your own data when you need it. Okay. Thanks for watching.